My name is Emily Bache and I work for Pagero as my main job, but I also have a small consulting business on the side which I'm keeping going at a very slow rate. But I'm talking today about Pagero. This is a very successful company in our field. You may not have heard of it, so I'll explain what our product does. It's a cloud service, and we help companies who want to receive invoices and other electronic documents in a format so that they can import them straight into their accountancy or ERP system in the right format. So they want to receive them from our cloud service, and so of course we have to get the people sending them the documents to also send them to our cloud service. So in a way we're kind of a meta integration service to help companies talk to each other more easily. And I've said this is a very successful company, and this transferring one document is a transaction for us. And the curve there is the growth in transactions that we've seen over about the last 10 years. And you can see that our market is quite predominantly Nordic, because every July we get a dip in the curve. But as you can see, the curve is rising quite steeply. We're starting to make quite a lot of money. We recently took the entire company, 120 people, to Aura skiing. So it's a nice perks at the moment. But obviously this puts pressure on the back end. We have to be able to keep increasing our traffic and scale the back end. So we started out 10 years ago with this JBoss monolith, Java, J2EE, and a database. And then for a while you can scale this just by buying bigger boxes. And this works. But then the next stage, of course, is that you want to cluster your JBoss application behind a load balancer and run it on several instances on several machines. This took us some way. But then about 2.5 years ago, when I joined Pagero, we started migrating to a microservices architecture to split up our application logic even further. So at that point, we deploy now our J2E application in a Docker, and all new functionality is written in Scala in microservices and communicate with Rabbit. And of course we can scale up the number of instances of our services quite easily. And this is working well for us. As I said, we've had this microservices architecture for a couple of years now, and we're breaking apart our monolith gradually. But right now you notice this database. We still have this one enormous database. And we're really, the last year or so, we've been working very hard to break apart our database. So we're going to move to Cassandra, and we hope to have this in production before the summer. So anyway, this is where we're going, and in the future it's obviously going to be even more complex and distributed. So how do we test all this? Well, of course, the traditional way to test something is through the user interface. We've been moving away from this as an industry for some time now. Now we have the agile testing pyramid. And when I came to Pagero, this was how it was actually. I was quite impressed with the scale of the unit testing that we had, and there were API tests and a small number of UI tests. So we have this when I came in. And now, of course, with the microservices architecture, you end up with a pyramid per microservice. So we had this for the monolith. And then, of course, a lot of the services don't have a user interface. So you just end up with the unit tests and API tests. Now, the API tests for a service are using the public interface to that microservice, and will mock out any other services that they need to talk to. And it will also, if the service uses a database, I'll let you have a database as well. And so you end up building this kind of stack of tests for each microservice. Some microservices, of course, do have a user interface, and at which point you might want to have quite a lot of UI tests, throw Selenium at it, and invest much less in unit tests and API tests. And that can be appropriate for some services. So I think one of the things with the microservices architecture, you can tailor the kind of tests to the service. But if you look at the overall picture here, there are a lot more API tests than you'd have in your standard monolith, because there are a lot more APIs. I think this is a really good thing. APIs are much more stable to test against than a user interface. Faster, reliable, less brittle tests. And they're also, I think, at a very good level of granularity when you have microservices. Unit tests, obviously testing classes and small things work, but they don't catch integration errors. The API tests will catch integration errors within your service, and they will also be a little bit closer to the business use case than a unit test. So I think it's usually a good balance between a test that's understandable to the user and finds integration errors, but is still fast enough to run and useful to have. So we're doing a fair amount of that. Another thing about this is you can reason about your microservices in terms of if this microservice fails, what's the impact on my system? Is it going to be very serious or less serious? And how likely is it? How confident am I that this is really quite a straightforward service that can't go wrong very easily, or is it a very complex thing with lots of code that, well, basically you find those ones and test them a lot and maybe invest less in testing the other ones. So this is another advantage of a microservices architecture when it comes to testing. You can tailor your testing approach. I still think, though, that you need to have full system tests. Michael was talking about how you deploy, orchestrate the deployment of a microservices architecture, and yeah, we've rolled our own as well. We have a tool called, we have platform recipe. We define a platform recipe. It says, right, I want to deploy all of these services, these versions, and they're going to talk to each other like this. And then I can take that recipe and I can deploy it to different machines. I can deploy my entire system on my development machine. This is the wonder of Docker. I'm really impressed that I can do this, and then I can run tests locally with my local changes, and the same tests then I can run against the same platform recipe deployed in the test environment where I've got lots of machines and I can have lots more data and I can test it there, and then the same recipe I then will deploy to production later, knowing that I've tested it already in more and more production-like environments. So I just said that. These tests that are testing the whole system are testing using a public REST API that we have, and we are able then to test with different sizes of database depending on where you've deployed it, so you get some kind of load testing. So we're using Go, the continuous delivery pipeline tool, as opposed to the programming language. And so it looks like this, that we have a pipeline building each service. So a developer pushes some code to their service, Go builds it, builds a Docker, publishes the Docker, and we publish a new recipe with that new version of the service, and then we can test that recipe with all different kinds of full system tests that we have. So we've got several different sorts of tests. So these are all, we'll initially run the whole deployed system on one server and test it there. If all of the tests pass in that format, then we deploy it to our test environment and run some more stringent tests, and then staging and ultimately production. Manual tests in the middle there somewhere. I don't really care about manual tests. So we've got these automated UI tests, Selenium, Jeb, selected important workflows. Feature tests is where the bulk of the testing of the actual functionality happens. And they're, as I said, using the REST API and a very small database. They create all their own data. Then we have these characterization tests, which are a dump of our production database. Well, not a whole dump, that would be far too big. We select certain transactions that we want to be able to rerun in these tests, and then we compare the results for the new code against the result we got with the old code, the production code. And if there is a diff, then we want to know why. And these tests have been extremely valuable, actually, finding issues for us. So that's been a success. And then we've got some other tests and some old tests, which I don't need to say much about. The other thing that we've started to do now is testing in production. So we have this whole thing to test our code before it gets to production. But sometimes we want to actually deploy in parallel the new version of the code with a feature toggle. So when you're developing a new feature, you'll develop it with a toggle. So it's toggled on when you're developing, and then if it's not ready to go out into production, you toggle it off when we're testing it in staging and production. But then at some point you can flip the toggle so that you're running in record mode in production, and that means your new service is just recording the results that it's would have produced and writing them to a file instead of sending them off to another service, basically. And then you can analyse how it behaves in production and compare it with the results you would get from the old way of doing things and check that the new thing is working. So we are doing that to some extent. We're just starting. We're not doing model-driven testing, which is a popular technique these days for particularly GUI-intensive applications. I don't think it's appropriate for Pagero, but it might be appropriate for you. We only have this one use case, basically, the transaction, and we're testing it very effectively with data-driven testing and designed data rather than generated data, as well as testing with the old production data, as I mentioned. So that is what I was going to say about how we are testing our microservices system, which is sending documents through the cloud. Our transactions are going through the roof. We have a lot of API tests comparatively compared to the old triangle. We can prioritize which services should get lots of tests, and we have this test pipeline for our continuous delivery. Well, it's not quite continuous yet. We're getting there. So that's what I was going to say. Thank you.